Hi guys, you are welcome to my channel. Today we're going to discuss about logic gate, logic practice. You're going to practice about logic, all right? Like I said before, this my channel is all about educating you, preparing you for automation space. Okay, my channel is all about taking you, preparing you for automation career so that whenever you register for automation, you won't find it difficult. You must have established a platform and also get acquainted to do's and don'ts and all the safety and all the necessary resources that you need to put in place before you commence the training. Okay. So after preparing you, you can now have a solid foundation to go into automation. I have a lot of students that are running the program now because we are not opportune to come to this particular space that I have. We are finding it difficult to navigate automation. So what I did was to take them back to relay logic. Once you register and I find out that we are not on the same page, so I will put it on hold. I will now take you back to a logic design, how to understand logic principles and how to use logic to control a process, to control operational process, thereby taking you to panel building and relay logic, contactor, and what is this other circuit that we call lashing circuit. You know how to lash circuit and unlash circuit, and how to build panel, how to do DOL, reversible motor starter, and start delta, and also design ATS, automatic transfer switch. So having gone through all that, I prepare you, ground you, have a solid foundation to come into automation, because automation is not where you learn connectivity skill. You must have gotten connectivity skill before you come into automation. Automation, you are on your own by reasoning. You think of what you want to automate. Okay. After you think about that, you have to design what you want to automate. After the design, you now come into automation to use PLC software to design that particular operation, that particular sequence of logic you have gotten before. You now use PLC to control that particular process. That is automation. You're not coming to automation to learn how to design. No. First of all, you learn how to design and how to control your process before coming into automation. Automation is to make it faster and more precise and efficient operation. That is automation, okay? I I usually give this example that if you are coming to learn AutoCAD software, AutoCAD will not teach you how to design. AutoCAD will give you the tools, gives you enabling environment to deliver your job faster, to make your job more global recognized standard. Okay, AutoCAD will not teach you how to do drafting. You first of all do your drafting first before AutoCAD now give you tools and give you interface to make it faster. If you are expected to deliver a job by 3 days time, AutoCAD will make it 30 minutes or 1 hour. All right. So that is AutoCAD. The same thing is applicable to automation. Automation will not teach you how to design. You first of all understand designing and the operation sequence of your particular design before you come to automation to use automation to control that particular process. Okay. All right. Now today we're going to practice logic gate. Now I know most of us have done that in our high school level days, but we don't know the application of this logic gate. Okay, but I want to give you the logic so that you know the pictorial view and the application of what you want to design. Now, for instance, let's start with this particular figure. This figure is talking about this is my load that I want to drive. Now, this logic says, how many cases do I have to initiate here before I get my load activated? How many cases? Let's start with number one. In one case, I will activate here. I will close this button, this particular switch. I will have power to my load. I will activate this load by closing this bit, this particular switch. Okay. Now, which other case will I activate to get this load energized? Is by closing here and closing here to get my load activated. That is two cases. Then three cases, I must close here and close here to get this one energized. So three cases here you must activate, not simultaneously, one after the other, whichever one you chooses. but this load must come out, must come on by activating this. And it should also come on by activating these two. It should also come on by activating these two. Okay, so three cases we activate this motor, whichever one you chooses. All right, now this logic is what I change here so that I could make it applicable to something lifetime. So something that I can feel and also design. I now change it to a schematic. From logic gate, from logic format, I change it to schematic. So in a schematic format, I have the switches line up. I have this other switch line up. The same way, these are switches, but in a different form. Okay. Now, for me to put on this load, let's simulate so that you make it more interactive. Okay. For this load to come up, I activate here. It now come up. Let me deactivate. I deactivate. How do I put it on again? In the second case, I put on here, it cannot come up. I put on here, it now come up. So it's all about continuity. Let me give you one particular secret. You must trace your continuity. If the continuity, like for instance, let me shut down. Then just listen to me. For electricity to flow, for you to have electricity to function, to flow from type a point of operation to the point of delivering of the action, you must have a closed loop. If there is open circuit along the circuit, you cannot have electricity flow. Electricity only conduct when the loop is closed, when continuity is steady from the point of starting and point of ending. So you must have a closed continuity. All right, you shouldn't have open circuit. If there's any open circuit, electricity will put on hold. It cannot flow. So bear that in mind that you want to have a continuity of a circuit before electricity will be conducted. So in that case, let me create that same continuity closed circuit. I now let's simulate again. For me to put on this load, I need continuity from the supply. I don't have continuity, so I have to put on this. I have load. So there's a continuity from here now to this place. If I shut it down now and I want to put it on from here, there must be a continuity from here to flow here. Okay, so that is how you understand the logic. Now this one now is this particular one. Now let's go to second figure. Let's work on this fig 2. So take away this logic. Leave my supply and leave this supply. Take away this. Then now let's build this by schematic. Okay, I have a supply. I have 1, 2, 3 switches or 4 switches. Let's create those 4 switches quickly. Okay, all right. I have switch one. Oh, I would have left that one so that I make it faster. I have switch one. I have switch two. I have switch three. I have switch four. Okay, now take it down. Take it down a little bit. Then take this down as well. Now I want to create a master switch. Just hold on. I have this too. And this is my supply. Okay. All right. Now let us tag their names. This is S1. This is S2. This is S3. This is S4. This is S5. Okay. Now let's link it up. Okay. Take this load closer. I'll try and give you the application of this. From the supply, I feed this one. I feed this one. I feed the whole of this. I hope you don't pay attention. All right. Now, finally, I supply my load. Okay. Now, this is what I have. Exactly what I have here. All right. I want to control this load using this logic. Okay. This one is the master switch. So let's call this master switch. Let's call it master switch. Okay. Okay. So the reason for the master switch, I will explain later. Now, let's see if we can simulate this. Okay. I want to put on this load by this switch. It's on now. I shut it down. I want to put it on by this. So any of this can put on my load. All right. Now, can we relate this to relatively what we can feel and understand fast? So this is also what we call start station. Start station. This is start station. This is also a start station method of controlling equipment. Okay, what is a start station? A start station is a method of controlling an appliance or equipment from various locations. Mr. A can control the equipment, Mr. B can control the equipment, the whole of these people can put on the equipment, but the equipment can shut down on its own. Okay, there are some equipment that has timing function. Once you put it on, it will work for a specific time and it will shut down. Now, I have four managers here that control a particular terminal. This four manager, manager one, manager two, manager three, manager four. Now, these four managers, their office is going to be located at different direction of the facility. So any of them can put on this equipment. Once you put it on, it is specially designed for self shutdown. You're going to have self shutdown function. Okay, supposing this is a water system, water pump, you now discover that you don't have water in your tap or in your office. There's no more water, and they want to pump water. You quickly activate this switch, and when the got water get filled up, there is a flow switch that will put it on, that will put it off. Let me just give that scenario. Okay, let me give that scenario that the function is that you put on equipment, but equipment shut down by itself. So I've given you two instances. Either the system has a timing function that when the time elapsed, the system shut down, or the equipment has a function of it has a, if it happen to be water pump, so water pump will come up, then by anybody here can activate the water pump, then it will shut down when it is filled up. So this application, I just give you two instances in which you can configure a system to use this particular start station. Then another way you can understand this start station is sometimes you see every earth moving equipment. Earth moving equipment uses some remote. They will have a mobile remote that has a start station gear on their hand. They will have it, or they will wear that particular gear on their neck and now walk like 200 or 300 meters away from the equipment. They can control the equipment with their belt, with their workstation. Maybe a safe loader that is loading a suspended load, heavy equipment. So it can walk a particular distance and remove that equipment to be coming up or coming down, or crane to be working. Then some other person can also be inside that same crane and also use that same button, another button that is default setting of the button of the equipment, to also operate that same equipment. Okay, so start station is a method of controlling equipment or a device from various locations by different individual. Okay, I just give example of four managers, one, two, three, four. This one will be located in four different offices. Okay, all right. I give you another miniaturized example that is so obtainable in our various locality. Supposing you are living in an estate that contains four or five flats. Okay, let's say a compound with four different flats. Tenant one will control this water from here. Tenant two will control from here. Tenant 3 will control from here. So all of them can control the water from their flat. You can put it on from your flat, but the water will shut down when you get filled up. All right. Or better still, I can put it on from here. Let me show you. If I don't have flow switch to control, I can put on the pump from here. I can also shut it down from here. Now, that is why we have master switch here. We have master switch here. Supposing the Mr. A put on the load or put on the pump, and the peradventure there is power outage. There is power outage along the line within the operation period, and they now forget to disable to de-enable this particular switch to shut it down, and now leave your flat and lock up everywhere and go. When power restore back, the equipment will still come up. Okay, but when it comes up and there is there's a necessity to shut down that operation, and you are not around, and nobody can access where this switch is located in your own apartment, you will now come to this master switch and shut it down. Master switch must be installed where it must be accessible to the whole of these people. So this one should be installed close to the pump location, while the rest of the switch will be installed right inside individual flats. So I've given you three applications where this can be useful. Okay, we have more than 1,000 useful of this. I'll just give you the ones you can easily access at your locality. All right. Okay, so we are done with this. So the application of this logic is what I have given you. Now, I will make up another video that will write a program using this format, using ladder diagram. Let me tell you, the whole of this logic, we have them in ladder diagram, ladder logic. There's writing PLC program. We use the whole of this to write PLC. All right. This one is a kind of complex, but we are going to discuss about this also. Okay. And we're going to also try to convert it to ladder, to schematic, sorry. We're going to convert this to schematic the way we did on this particular one. All right. We have done this one for this one before. Then we have also did this for this. This is this. All right. So the next exercise, we are trying to see if we can cover them, convert them to schematic. So that by the time you come to automation space to write program using this, because this is actually for automation skill. Okay. This particular logic, you know that when we are preparing student, even from high school, it is also assumed that you are preparing them for any innovative technology. Although some people know about this, but they don't know the application will come to play in automation space and in a control system space. Now, the application is now in your doorstep, waiting for you to activate that particular knowledge. So that's what we're going to do. All right. So let me now use another video to do this. We can convert this. Then we'll do a ladder logic to also control this particular logic practice. Okay, so before you write a program, understand logic, the principles of logic, how you can apply logic to control a process, operational process. How can something open? How can something get activated by using logic method? All right. Okay, now thank you. So let's go to the second exercise so that see if we can complete this by converting it to a schematic and also relate it to live situations of a function. All right. All right. Thank you.